thing you want me to go over is further graphs extension 1. To revise for these, as you can see what I've opened up here, they're actually part of the 4-unit course. So further graphs was part of the old extension 2 course. So the best thing is just to go to HSC papers and you'll pretty much find them. Here's the one right here. Let f of x equal to negative x squared plus 6x take away 8. And then of course, on separate diagrams and without using calculus, sketch the following graphs, indicate clearly any asymptotes and intercepts with the axes of all these 4. You're not doing the 5th one, you don't do exponential f of x's. So we're going to go ahead and do this. And if you know the basics, then realistically, I guess the hardest original graph you'll get, you'll be able to transform it because you know the basics really well. So let's do this. A question that has this, I first look at that and I go, okay, well, I know that's a parabola. So if I'm going to draw y equals f of x, the first thing I would need is my intercepts. So when x equals 0, I get y equals to 8, negative 8. When y equals to 0, I get positive x squared minus 6x plus 8 equals 0. I just multiply everything by negative 1. You can probably factorize that easily now. Won't work, would it? Oh no, it would. X minus 4, x minus 2 equals 0. Therefore you get x equals 4 and x equals 2. And then of course, don't forget, it's a sad parabola, so when you're going to obviously plot it, 2, 4, you're going to have a y-intercept of negative 8, and it'll look something like this. Really bad parabola, but I think we understand. From that, it doesn't say find the vertex, it just says asymptotes and intercepts with the axes, but I think it's a good point to make. Let's sub in what 3 is and work out what the highest point would be. So y equals negative 3 squared plus 6 times 3, 18, minus 8, negative 9 minus 8 plus 18 gives you 1. The reason why that's important is because we're going to transform. We need to know if that wasn't 1, then your y values are going to change as well when you square root them or when you find reciprocals or whatever it is. Okay, let's start. Double I. Y equals absolute value of f of x. What do we do with absolute values? Absolute values of f of x. So what do we do with absolute values of f of x? Come on, what's the first thing that came to your mind? Yeah, whoever that is.
Negative values reflect up.
All negative y values reflect up. Perfect. So therefore, there's your 2, there's your 4. It's at negative 8. It should cut at 8 now, and it'll look something like that. These are sharp, so it's important that you know that they don't look like this. They don't look like your normal W's that you might be used to in polynomials. So it's important that you understand these are actually sharp because it's a straight reflection of this. Good. There you go. Remember, these are 4-unit, but there's no such thing as extension 2 or extension 1. It's just if you know your stuff, you apply it. Doesn't matter what part of the course it is. Doesn't matter if this was part of university. You just really learn it and you apply it. Here we go. Y squared equals f of x. Y squared equals f of x. So in other words, y equals plus minus square root f of x. Okay, what do we do with that one? What would you do with a y squared or with a square root of f of x? What happens to that one? Anyone know? Not so confident. I'm sure there's someone that kind of knows it. Give it a shot, even if it's wrong. Novak, what would you do? with y squared equals f of x?
Is it the weird circle thing?
See, you've memorized it like that, but it's more important to memorize the way, like I think Nada said it here. Let's say reflect all your y values, your negative y values up, right? So it's important to know what you're trying to do with these ones, because it's not always going to be the original, like a case like this. So it will be what you said, but it's important to know what's happening. So it's all the positive y values. So think of it like this. Think of it in terms of logic, because I can see you guys were struggling with it. Forget the first one here. Imagine the second one. Imagine you've got plus minus square root f of x. What value is f of x? Are these x's or y values when we say f of x? Y values, right? So you're looking at all the y values of this. Here, look at this. What happens to all these y values? And what happens to all the y values of these? So imagine the square root of negative 8. Won't work. Square root of negative 6. Somewhere here. Won't work. Square root of negative 4. Won't work. Do we see that now? So the truth is, with these ones, it's got nothing to do with, obviously, the negative y values. It's all about the positive y values. So the idea is positive y values don't exactly just get reflected down, right? It's not positive y values get reflected down. It's the square root of the positive y values. But the square root of all these numbers is only going to make it smaller, right? Because the square root of this number is only going to get small. Square root of a half is going to be 1 on root 2, which is somewhere down here, and so on. So what will really happen is you would get that, I guess, that circular shape. But it's important to know that it's more like this, you know? It's a bit smaller than the original one you would have drawn. And then the reason why it's the top and the bottom is because there's a plus and a minus. If it was just a plus, then it's just the top bit. So with this one, what you would write is positive y values, pretty much get square rooted and then reflect down via square root. So it gets reflected down, but it's also square rooting it. So you don't forget to square root. And last one, IV. IV equals 1 on y equals 1 on root. Y equals 1 on f of x. What's the steps for our reciprocal functions?
You would put the asymptotes on 2 and 4.
Yep, perfect. That's step 1. See, again, just by you answering that, you've just worked out what you're strong at. You've worked out you're strong at double I. You're like, all right, cool. I think I get this one. I get reciprocal functions. Maybe I don't understand these square roots very well. So you don't need to go and study everything all over again. You'll make a note of triple I and start working on a lot of triple I questions until you can answer it just the same way as you answered IV. Yep, there you go. Anyways, asymptotes at intercepts. The reason why that occurs, again, don't forget you're doing f of x, which is y values. The y value here is 0. So 1 over 0 is impossible. 1 over 0 is impossible. And then 1 over a very small number becomes a very large number, and so on. So the way I would have said it is, if it's sad, up here, it'll be happy. Lowest y value is 1, because the highest y value you had was 1. And there it is. And then over here, 1 over a very small negative number should give you a very large negative number. 1 over a very large negative number down here somewhere will give you a very small. What's super important about this point right here? What number must that be?
8.
If it was, no, negative 1 on 8. Right? Because what are you doing? Aren't you doing 1 over the f of x's? 1 on f of x, which is negative 8. So that's super, super important. And then this side here, there's nothing to do, so that's negative 1 on 8. Really, really important. And that's it. Okay, let's do some more. Any questions about those? All right. Cool. What's going on?
Then when do you do the parabola on the side?
When do you do the parabola on the side? Wait. When do you do the parabola? Like when would this be? When would it be?
The side.
Are you talking about IV or are you talking about the original case?
No, like, because I thought triple I would be on the side.
Ah.
I don't know.
No, I know what you're saying. Okay, triple I. You're talking about this case where the graph becomes this.
Yeah, that one.
That one for this graph. For this graph, it would be all negative. Yeah, no. It won't really happen with your normal transformations. Let me think about it. What do you think? Can I make it happen? Can I make it happen for you? Not really. Okay, it's not for that one. It would look like this. So your original one, and see, I think you just did what Anouk has said, because now I realized what you're saying. So he had said for this triple I, he said, is this one just a circle? And it kind of is, right? But I said it's better to understand that it's positive y values that get reflected down by the square root. And you said for triple I, isn't it this one? And you are right as well. It is this one. But you know for which one? It's that. It's that for this happy parabola. Why? Because again, let's follow this rule. Positive y values. Well, where's my positive y values? My positive y values are here and here. So I ignore the bottom now. They get reflected down. But a reflection down would have been this, which is actually absolute value of y. So absolute value of y would be that, which is very close to y squared, because they're both positive. That's the logic. But the difference between absolute value of y and the fact that it's y squared is when you do y squared, you're square rooting, technically. So it's not a straight reflection down. It is a reflection down through the square root. So which means what you're going to do is this becomes more like this. Because what's the square root of these large numbers? Well, the square root of these numbers will be these ones here. They'll be slower, right? And so on, and down here. And this one becomes your sideways parabola. Does that make sense?
Yeah.
So instead of, believe me, instead of trying to memorize just that, like the fact that it's just like a sideways parabola, or it's a circle, which is good. It means that you understand the square roots and what's happening. Because what I would have taught you guys to do is memorize the original case, and then memorize what happens to the original case, but not so much memorize the shape of it as explicitly being that all the time. So it doesn't have to always be a parabola or a circle. It could be anything. The idea is you're meant to look at the original, you're meant to know your blue answer, and then you go, okay, what has happened? Well, what I can see has happened is all my positive y values got reflected down through a square root. If it was this one here, or if it was the y squared, you would be like, well, I can see that it almost looks like that, but it's actually square rooted. So it became a sideways parabola. You need to know it like that more than memorizing the shape. Because I mean, the original graph could be literally anything, and we're going to see some now as we do them. So, but yeah, good. Like, it's okay to have memorized it, but don't think it's explicitly that all the time. That's all. It's good knowing it's a circle, but it's important about understanding why is the circle happening. Oh, you're just getting rid of the bottoms, and that's it. All right, that's cool. So let's do some more. Yeah, I think that's a good one. All right, let's do that. So again, if you need Anouk, where are you going to find your questions for further graphs? Extension 2 papers.
From.
Okay. You just go to HSC, extension 2. They're always question 3.
Can you send these book lists to the chat as well?
Yeah, I'll send it to you. No problem. You don't need to do the E, F of X's. I don't think that's part of your syllabus, if I recall right. I don't think you guys got taught absolute value of x. Oh, no, you did. I think this one, yes, but absolute value of y, you didn't. But I do them anyways, because it's important to know them all, I think, in case one school, one test, something they just want to test if you actually understand what you're doing compared to you've memorized what to do. So we'll do all of them anyways, and just to make sure we understand them. All right, let's do the original case. We're going to graph this. I think the first thing I would do with a question like this is, and it's important for you guys to learn this as well, is to split this up with common denominators. So the trick to it is to do that, and then what you would realize is, that's just a hyperbola that's shifted down one. Whereas a lot of students would usually miss that. They would get the fact that x cannot equal to 0 from the original, so they'll know that there is no asymptote, or there is an asymptote here, sorry. There's no x values that can be 0, but they usually miss the fact that there's also an asymptote here. Shifted down one. And the reason why they would miss that is because they would have not done division or splitting off of your denominators there. So that's what I would do. And then obviously always, find your x and y intercepts. When y equals to 0, you would actually get x equals to positive 1. Now I think that's already a giveaway why that can't be an asymptote there, because he actually intercepts. And voila, and that. All good? Let's do as many as we can. Let's do that one. Let's do this one. Triple I. We'll make it into a 1 on f of x. V. We will do, what else have you guys learned? Y equals absolute value of f of x. And then VI, the one I don't think is in your syllabus, but it's from the same family as these two, so why not learn it? And then just for fun, we'll combine a few things. So we'll combine this one with this one like that. So this double I is going to be absolute value. That's how you would do it. All right, let's do each one and see if we actually fully get this, and if we do, then I'll move on and we'll start doing the exams for other topics. All right, double I. Double I. Y equals absolute value, sorry, y equals f absolute value of x. How is that different to v? What's the first thing that you realize is different? Let's get that clear.
It's the absolute of just x's.
Yeah, cool. So these ones are y values were reflected up. These ones are x values must always remain positive. Now it is a little bit different. So it's not like this one here where we did all negative y values get reflected up. It's not exactly like that. This one here is all positive y values, all positive, sorry, x values reflect about y-axis. So all positive x values, all of this gets reflected to the left, and that's it. That's double I. I can't make that any easier. So all of the left-hand side you ignore. There's your 1. There's your asymptote. There's your asymptote this way, and there's that. And there's that. -1. And just a note, since we're here, if you ever had a question that said y equals f of negative x, you don't go, oh, I don't know what to do. No, it's exactly that, right? Negative x is this one here on the left. So what you do with negative x is all positive x values become negative x, and all negative x values become positive x. So it's a straight reflection about your y-axis. So for this one here, it's a reflect y-axis. Just like you would have done it for this. Negative f of x. You would have reflected about the x-axis, right? Your happy parabola becomes a sad parabola. So this one here, all your positive x's become negative x's, all your negative x's become positive x's, which makes sense because negative of negative numbers should become positive and negative of positive numbers will become negative now. So, and then if I combine the two, what you're doing is you're only taking where x was originally positive, so that's why we're going to take just the top bits, and then you would ignore the bottom bits, because those guys won't exist for absolute value of x, because you'll never have x being negative in the first place. So that's double A. Okay. Any questions there? Okay, triple I. Again, same rule, 1 on f of x. We're going to find our reciprocals, which are right there. Find our asymptotes, which are just there. And there's that. This is maybe a little bit more advanced, but it's good. Your horizontal asymptote, 1 over negative 1, still doesn't change. So that's at negative 1. Okay, let's do bit by bit, right? So don't rush it. All right. Now let's do the right-hand side first. Let's start with this side. So what's 1 over a very small negative number? What are you guys going to say? 1 over a very small negative number.
A large number.
A very large negative number, right? So it's going to start down here. Now what are you going to do, Andy? You're obviously going to, you're going to follow your normal trajectory that you would follow. Now, do I cut the asymptote, or do I just approach the asymptote?
Approach it.
Sometimes, just so you guys know, right? Sometimes you can cut. Now, the reason why you're going to approach in this case is because the maximum you're going to get to is, let's call it 0.99999, right? Negative 0. Now, on your calculator, do 1 divided by negative 0.99999. I'll put 5 nines, for example. That still gives me, if you see the answer, it gives you negative 1. So 1 over negative 0.9999999 gives you negative 1.00001. It's trying to tell you that it will never cut negative 1. It's going to approach negative 1. It won't cut negative 1. So I think the conclusion we can make is that, yes, it will approach this asymptote. So this right-hand side will look exactly like this. Okay, now, what's 1 over a very small positive number? I think it's safe to say we know that that's going to become a positive large number. What's 1 over a very large positive number? That becomes a very small number, right? So, in fact, what's 1 over infinity as this approaches infinity? What's 1 over infinity?
Tiny number.
Yeah, well, how tiny are you saying?
Very small.
So what number?
I don't know.
0. Right. So you're saying, okay, as this approaches, as this black line's approaching the asymptote, this orange line needs to start approaching 0. Okay. Well, we'll get back to that in a second. What's 1 over a very large negative number? Now, just a little bit after this asymptote, what's 1 over a very large negative number? Well, isn't that a very small negative number? So somewhere up here. And then, what's 1 over what's 1 over a number close to negative 1? So it's going to be very, very small.